So just remember, this is P, and everything starts with a P. And remember percents. That will help you too. When we did your other things with your means, we did 2 units, 2 little sections on the sample means. We found a point estimate for your mean, which a lot of you keep forgetting. Your point estimate for the mean for the population was your sample mean. That's the only information we had. And way back, we kind of proved that your mean from your sample was the same as your mean from your population. Now we're looking for a point estimate for a P, for a proportion, for the population, because again, we don't know enough information about the population. So now, we have to find our point estimate using our sample information. Again, we're going to do the same process. We're going to take proportions for the samples, whatever they give us. We're going to create a part over whole, create a proportion. And this little thing here is called a hat. So this thing right here, we pronounce SP hat. This little guy right here with the Q hat, we pronounce this as Q hat. The same as we did your X bar for sample, we have to have a way to show sample. So we show it with a little hat on top. That comes from your sample. Again, let's just go through this part, what we're using for this. We have a population P. This is a proportion. We have a P hat. Okay? We do a Q for proportion. We do a Q hat for sample. Same as we did the mu and the X bar, population versus sample, we do these as well. Okay. N, again, is still the number in your sample. So we're creating point estimates for our population based on what we have in our sample. We did that with your means. We have to do that with your proportions. Excuse me. Allergies are kicking today. So just remember, we just call this P hat. We have to have a way to separate it from the proportion. It's actually a very easy little section. There's really not a lot to this section. In a survey of 1,000 U.S. teens, there's my N, 372 of them said they owned smartphones. There's my X. Find a point estimate for the population proportion of U.S. teens who own smartphones. Now, I don't know the population proportion. I can only take my sample and make a point estimate, make an estimate for the population. So I'm going to take what they gave me in my sample, and we'll have to make this point estimate like an inference against my population. So I say P hat is X over N. All you have to do, part over whole. Proportions are part over whole. Just divide it out. This one divides nicely because it's based in the base 10. This is my P hat. From here, we find your Q hat the same way we always found your Q. 1 minus P. So your Q hat is 1 minus this guy. Okay? That's all it's asking you to do. Find a P hat, find a Q hat. Point estimate again is something we can find from our sample to make an inference about our population. Because otherwise, we don't know anything else about it. And then later, we'll work off of this, and we'll do our z-score thing with this. It's just so that you get what this proportion means. Good? All right. You guys try the try it one. Try this one. Find me the N, find me the X, and find me your point estimate. Your point estimate, the only thing we know for a proportion is the proportion itself. So since we're dealing with a sample, we call it a p-hat. So what's the N here? Here's my sample. This is my sample of U.S. teachers, because obviously I can't reach the whole population of U.S. teachers. And I asked them, and 123 said that all or almost all of the information they use finding search engines online is accurate or trustworthy. This is the X part. It's kind of scary out of all of those numbers, and only 123 say their information is trustworthy. That's kind of scary. So my p-hat says X over N. If it's not on your note page, put an example out there so that you understand this is called your point estimate. Oops. We don't know about the population, so we're using our sample to help us make an inference about our population. So we have to have a starting point. We're going to make an interval, but we have to have a starting point. Okay, so you're going to say 123. And so what's your p-hat? Try to go 3 decimals, and I'll show you why in a second. So 3 decimals would give you what? 0.45? 0.4. Okay, so we're going to go 0.049?
Around 0.05.
But I need you to go 3 decimals.
Yeah, but it's...
Oh, it came out to be a 0. Okay, it came out a 0. Okay, thank you. Because what happens in a proportion, if you flip this to a percent, and you only hold, say this had 1, and you only hold 2, you're saying that this is 5%. You kind of cut off the fact that it had any kind of decimal. So on your p-hats, q-hats, if you can, go 3 decimals. And then your q-hat is obviously 1 minus this guy. So 0.950? Right? 0.950. 0.95. Okay. Now, it's pretty simple from there. Once you have your p-hat, just like your x-bar, you build your interval. Your interval says, take your p-hat, plus or minus your margin of error. Again, just like before we had a margin of error for the z, we had a margin of error for the t, we have a margin of error for the proportion. And the zc is back to where we were before. Okay? Because this is like a binomial situation, and hey, Renee, you're going to do your test on it as well to make sure that it works. And you're going to find whatever it is your percentage of ZC is for whatever percent error, confidence you want. And you're just going to plug in these values. These are your p-hats in here, divided by n. You can put this, we'll do a couple together, and we'll see what they look like. But I will give you the formula again, and after we do one with the formula, I'll show you on the calculator. It's nice on the calculator again. So again, for constructing this confidence interval, we identify our statistics. We have even less to worry about. We have an n, we have an s, a part and a whole. We find the point estimate. We create a proportion. We verify that we can actually use this. That it approximates a normal distribution. This is in lieu of the problem saying n is greater than or equal to 30, or it approximates a normal situation. We go back to your table 4. We do this again. If it's 90%, we put 90 in the middle. We do this on your inverse norm again. We do 1 minus 0.90 divided by 2. We find your positive ZC value, what we did earlier. We set up your margin of error. We find your confidence interval. It's that simple. This one is a really, really nice one. So let's take a look at one. Keep this handy so that you know your steps. Spot on my board. All right. So we're going to construct the 95% confidence interval for those U.S. teenagers that own smartphones, which came from the first example. So your first example, this p-hat, it had 1,000, this came from your first example. 372 of them said yes, they owned a smartphone. So our p-hat and our q-hat was 1 minus this. Thank you, both all of you. Thank you. Okay, so now all we need to do is this: p-hat plus or minus e. We'll do it by the formulas first, and then we'll do it with your calculators. So E says this: I need to find the ZC for this 95%, which we've been finding before, which we probably even remembered. I need to take my p-hat, my q-hat, divided by n. You can put it right like that in your calculator. Now, for your 95%, again, inverse norm, 1 minus 0.95 divided by 2. You are back to your z-score for this. Back to table 4 if you like to look it up in table 4. So this gives you 1.96, your p-hat, your q-hat, divided by, all under the square root, divided by n. Some of you get confused what n is. I notice on the test, your n and your other things kind of get mixed up along the way. Always write this out. Always take out your information. Make yourself an information box so that you go back to that instead of, I think what happens is you go back to the word problems and you just pull out whatever number you see in there. Because some of you were off on your n's when you did your formulas. This you can put right in your calculator just like you read it. Order of operations will work for this. So if you just say this, 1.96, then do your square root sign. And most calculators. Square root. If you just say it this way, 0.372 times, just like you read it, 0.628. You don't need any extra parentheses. Divided by 1,000. Notice this is all under my square root sign. Order of operation says multiply this, divide this, then take the square root, then multiply it by 1.96. So as soon as you do that, you get your answer. Now look how small it is. It's this small because it's a proportion. It has to be less than 1. It's a proportion. It's a part over whole. We were always less than 1. So this is going to give you, and rounded to 3 decimal places. Rounded to whatever your p-hat or your q-hat is rounded to. If your p-hat and q-hat came down to 2 decimals or 1, then round this one. But most of the time, keep these 3 decimals. Because if we looked at it in percentages, which we will in a second, we want to be able to move this over. So we just take your p-hat. So your p-hat was 0.372 plus or minus 0.030. Very easy to build. Write it out. Now, the interpretation's a little trickier on this. I want to be 95% confident, right? That my proportion of all U.S. teens who own smartphones for my population fall between these two proportions. It's kind of a weird way to say that, isn't it? That it falls between these two proportions. Sometimes you're better off looking at it as a percent. I want to say that the percent of all teenagers in the U.S. who own smartphones will be between 34.2% and 40.2%. Sometimes it sounds better. It sounds better to me in percentages rather than saying the proportion of 0.342, because it really doesn't mean a lot. So that's why we go 3 decimals, so that if you move your decimal place 2 to give you a percent, you still made sure that you had some kind of an extra decimal in there. That is it to proportions. Now on your calculator, it works real nice on your calculator too. But the only problem is, we're still looking for an interval, so let's pull up all our intervals to the top. And we're looking for something that says proportion. And what did we use, a Z or a T? We used a Z-score. So can you tell me which one this would fit into? How many proportions did we build? 1 proportion Z interval. You're only looking at your intervals, right? We're still building an interval. We use this guy, we use this guy. Do we have 2 samples? No. No 2 samples. Do we have 2 proportions? No. We only have a 1 proportion. Look how easy this was to find. All your intervals are so easy to find. A 1 proportion Z interval. So if I go here and I come to A, this automatically tells us, just enter this, I'll figure everything out for you. Enter your X, enter your N, enter your confidence interval, and I'll calculate this for you. And I'll even show you your p-hat. Did we get this p-hat? They got it for us. There's my confidence interval. Now, same thing works for margin of error. It's even easier, because your x-bar used to be there, now your p-hat is there. Just put your p-hat right under here, and subtract it. Round this guy first. Round it to the 3 decimals, and then subtract it. And you'll get your margin of error. Works the same way. The calculator on the intervals are really, really nice. They're easy to spot. They kind of do the work for you. And you can work yourself backwards. And some of you, I noticed on the test, did the interval, then subtracted it, and give me a little arrow, and put the margin of error there. That's exactly fine. So again, it's up to you. I really encourage you to try the calculators on these. They work really, really well. All right, so I'm going to have you guys try it too. Now, in the first part, I'll give you the N. We had a survey of 2462 teachers, and the X, this is the X, is 123. And our p-hat was 0.05, 050, so our q-hat was 0.95. So from there, we're going to build me a confidence interval. Try the formula, like just try it, make sure you're comfortable with it. Try the margin of error formula. So let's see how this works. Let's do your margin of error formula. And again, I will give you the formulas. Just remember that that whole thing fits inside that square root sign. So we need a 90% confidence interval. What is your ZC for 90%? Good. And very good. You got the whole thing. 1.645. Because Kaylee did inverse norm. 1 minus 0.90 divided by 2. And came up with that. So we plug these in. 0.05 times 0.95 divided by this mess number. What was that? 2462. Thank you. So what did your margin of error come out to be? We can go 2 decimals. Since this is 2 decimals, give me your margin of error 2 decimals. Or not. Give me your margin of error 3 decimals. 3 decimals. 007. I knew when I said 2 decimals, if you had around that, you'd all be saying, uh-oh. All right, 3 decimals. That's pretty small, isn't it? It's a less than a percent of wiggle room here. All you need to do is this. P hat, 0.05, plus or minus 0.007. You could put a little thing here. Okay? And this is going to give you 0.043 to 0.057. So somewhere between 4% and 5% of U.S. teachers, I can make this statement that I could be 90% confident that between 4.3% and 5.7% of all U.S. teachers find their information trustworthy. This is pretty sad. If you think about it, really, they're using information that's not trustworthy. They should be high. They should be confident that their information is good. So are we feeling okay about this? Terrific. Good. Of course we did the N times P and N times Q thing. Of course we did that in our heads. Okay. So, try 3. Let's do one more of these, and then we can be sure that we have this. So you're going to use your book to figure this out. The figure shows a survey of 498 adults. So this is my N. My confidence interval. What's my ZC for a 0.99 confidence interval? Good. 2.575. Remember, they're always positive. Okay? And what is the proportion of adults according to your chart that think teenagers are the most dangerous drivers? Sorry, guys. What is the proportion of adults that think that, according to that survey? You have to look in your book. Go to example 3. Find me the percent that think teenagers are the most dangerous drivers. 0.71. So if this is my P hat, what is my Q hat? 0.29. I'm still, this many people were surveyed. I have to make a statement about my population based on this sample. So if I had to pick out 71% exactly, that'd be pretty tough to pick out 71 exactly. So again, we give ourselves wiggle room. We set up an interval. Should we say 0.71 plus or minus whatever my margin of error is? So we found our ZC. We know our P hat. We know our Q hat. And we know how many is in our sample. Round this to 2 decimal places if you can. So round it to 2 decimal places. What would that number be? 0.05. Good. It was 0.0499. Just round it to this guy, the second decimal. So now all we have to do, 0.71 plus or minus 0.05. So again, we get, sorry, that wasn't it, right? 0.05, this was wrong. 0.052, right? So rounded to 0.05, sorry. So take this and subtract it and add it. Gives you a bigger range. This is 5%. 5% is a big to or from. Think of the margin of errors that you guys did when you did the presidential elections. Those are usually like 3-4%. So 5% is a nice little piece of wiggle room here. Okay, because your confidence, look where that difference is. Your confidence made this guy, this is 2.575, made this guy a lot higher than 1.96 or 1.645. Even we did a 1.645 for 90. So when you're multiplying by a larger number, you're getting that bigger margin of error. Because again, the more confident you want to be, what happens to your interval? It gets wider. Good. So that holds with this too. We see the same exact traits for this.